Hi, in supervised learning, we have seen we have input data and we have the output labels associated with those input data. We saw an example where with the quality of signal, there is a throughput which is associated with it, and with the changing input value, which is signal of or the signal quality, there is a change in the throughput also. In case of unsupervised learning, which is another type of machine learning, here what is happening, we have input data, but we don't have output labels in this case. So we may get some data in terms of a different traffic which is coming from the network, and different user is having a different type of traffic pattern in that case. So we got a different data got from the network in that case, say for example, and we just put it in the machine learning model. And then what it gives is basically it gives a correlation that what are the different sets of data we are getting, which particular area or which particular users are having lower traffic usage in a particular time frame, and some other users are having a higher traffic usage at that particular time frame. So we can make some kind of clustering using this particular type of machine learning, which gives us insight about how the patterns are, how the correlations is between the different data sets which we got from the network. There is another option which is anomaly detection in that case, where we can see that by using the unsupervised learning, some of the samples, they are not making any kind of cluster, and they are kind of outliers which can be used to identify the issues for those particular users or for those KPIs in that case. Now, the third type of machine learning is reinforcement learning, where machine is actually learning by doing some trial and making some error on it. So there is some correlation that has been made already in a model, and this model while running will evaluate that, okay, the agenda and the motive of that particular model or the machine learning type is actually being achieved or not. So say for example, if you want to achieve a lower interference in the network, and we have made a reinforcement learning in that case by making some model, and we'll talk about machine learning model in the subsequent slides. So once that model is there in place, is the machine is able to give the outcomes as per the requirement or not. So it'll keep on doing some trial and error on that particular data, and every time when the data is fed into the system, will it give that outcome? Say for example, we want to reduce the interference in the network, and this particular model, when fetch the different input variables from the network, is it helping to give us or tweak the parameters in the network to reduce the interference or not? So we have certain different examples in that case, maybe in network by using the reinforcement learning, some of the parameters within the antenna, advanced antenna techniques that will get tweaked as per the requirement and reduce the interference in the network. Or it can optimize the traffic depending upon the kind of behavior or the scenario on the ground, depending upon the different input variables in the network. So if this particular model, machine learning model, is working fine, it will be rewarded every time for that giving right output in that case. But if this model is not working as per the requirement, as per the need, there will be error added to it, and it will be considered as a bad action, and there will be a penalty associated with it. So what it does is with every iteration, it keeps on checking that, okay, it is working fine. It will be rewarded every time. If it will be rewarded more, and it will be considered as a better machine learning model in that case. Whereas in case of a bad action, it will be penalized every time. And then in that case, this machine learning model will not be used in that case. So this is how the reinforcement learning works in real case scenario. Thank you.